Hello guys, welcome back to my channel Algorithm Minds. My name is Asan Khorom and in this channel I teach programming skills in Python, Matlab and R programming. I also teach Tableau, a data visualization tool. So for today's tutorial, I'm going to teach you how we can actually implement this function of Matlab called fzero and calculate a point for a function where the function has a value equal to 0. This is a solution in where function x of x changes sign. So f0 cannot find a root of function such as x squared. So let's move on and see how we can actually use this function. So first of all, let's move on and talk about root starting from 1 point. So we will take 1 point. So we want to calculate the pi by finding the 0 of the sign function near 3. Okay, so how we are going to do that? First of all, we are going to define function. So we are defining function here with the help of function handler at a rate sign, and we say that the function is sign of x. Okay, then we will define the initial points. Once we define the initial point and the function, all thing we have to do is to call the function and pass two input argument. The first input argument is the function itself and the second input argument is the initial value. So when we call the function and calculate the value, and we will like to store that value in a variable called x. Okay, so when you run it, you will see that the function is being operated and we get a value where the function has a value equal to 0. Okay, so we have an initial point. Now let's move on and find the root of the function, starting with having some sort of intervals. So we will find the 0 of cosine between 1 and 2. We would like to find the 0 of cosine between the intervals and 1 and 2. So I will teach you how you can actually implement that logic on this function f0. So first of all, we are going to define the function. In this case, function is equal to @cos colon, and you know that this is a function handler. If you are not familiar with this kind of logics in Matlab, I suggest you to go and watch my video on functions in Matlab. It is a highly resourceful video. You will learn a lot from that video. So we have defined the function. The next thing we are going to do, we will define the x node, and now this is where we will define the intervals here, okay, in the form of array. So you can see that we have the minimum value and maximum value in the form of array 1, 2. Okay, now we have defined the initial interval, we have defined the function. All thing is left to do is to call the function f0 and pass two input arguments, and we are good to calculate the value at which we have a cosine values equal to 0. Now there are plenty of options that you can alter while using this f0 function. For example, x is equal to f0, which is then it takes 3 input arguments. The first is the function itself, the second is the initial interval or initial value, and the last one, third, is the options that you predefine before calling the function. So this type of definition of function calling uses options to modify the solution process. So I'm going to show you how it is done. So we are again defining a function here. Like you say that we are using @rate sign, which is the function handler sign. Then we are saying within the round brackets that this function would be a function of x value. Then later on we will define the function that is dependent on x value. So we have like x sign value, sign, and within the sign we have cos h, and the cos h is of x. So by default this function is a function of x. Then we define the initial value. Now here we are defining the options. Okay, you see that we have declared a variable option, then create its value by calling the function opti_mset. So this is how you can actually define the options for a specific function in Matlab. So we will use opti_mset, and round brackets we will pass number of input arguments. Okay, so we say there, okay, we want plot, we actually want a plot function. So we actually is telling, by setting this option with that, with the help of this options, we want to visualize the iteration that this function f0 does, and we want to visualize those values. Okay, so here we are defining the argument plot function, and here we are setting its value that we want to plot the x values and we also want to plot the f evaluate values. Now that being done, so all thing we have to do is to call the function, then pass the input argument, the function itself, initial value, and the option that we have declared earlier. Now when we run it, you will see that we will get some plot, some sort of plots like this, which shows us the value of x value and also shows the f evaluate value. That you can see that it starts with 0.1, then finally it approaches 0 value. Okay, so that's how you can actually visualize how the process of iteration, how the f0 approach was done to reach a 0 value that start at particular value and finally reaches a 0 value of the function at which in order to find the value of x that gives the function value 0. Now there's another approach that how you can actually define this pass input argument to this function f0. So here is it, x is equal to f0 and within the round bracket is problem. This problem in this case is a structure notation that solves a root finding problem specified by problem. So now you can see that the problem is being defined in the form of structure. Here dot is always used for structure notation. So just like in the previous case that we were defining the function, in this case we will define function by using problem dot objective is equal to @ and then within round bracket we said that it's the function of x, then we will define the function itself. Then we in the next line we are defining the initial point by writing problem dot x naught then equal to the value of it. In the same way, we are defining the solver that we want solver to be f0 required part of structure. Okay, and option we are like which is the default option. This doesn't mean anything. I mean it's remain the same thing, so you can actually neglect it if you want, but if you want to put it you can write problem dot options then optmset just like the way we have used earlier, and then we will say @f0 that this is the option of this function f0. So this is how you define a problem in structure notation and pass it as an input argument to this function f0. So now you can see that when we run this code we get the value of x for which this value will be 0. And now there's a bunch of other important features that you can actually use. For example, we have like x value which gives the value at which the function is 0, and f value is actually the value of function at that specific x. Okay, then it gives us exit flags and output, that is like it gives us the iteration process, and you will see in a moment. So this approach returns a function xx in the fval output, encodes the reason of f0 stop, like it gives us the reason why the iterations were stopped, and an output structure containing information on the solution process, like how this approach. So in this case it is giving us the updated values of function and x at every iteration. So how we can actually define that? So we will first define the function. Now you can see that this is the same thing. Then we define in the initial value. In this case, we are using an interval, and we are also setting options by calling the function optmset. And here we are passing argument that we want to display, and we want to display what iteration. Okay, so it's an argument value pair. Here we are using to define the options. So next thing we are going to do, we will write the 4 outputs x, fval, exit flag, and output in the form of array. Then we will put equal to sign, then we will say f0, then function, initial value, and options. Now you can see that it is giving us the value of x and function at every iteration. And once the iteration has reached a value of 0, it gives us the exit flag that we have, that is that we are able to get the function value equal to 0. And it finally gives us the statics, like how many times the iterations were conducted, and with some summary of the output. Okay, so this is how you can actually use f0 functions in Matlab. I hope this tutorial have been helpful. If you have any question regarding today's tutorial, feel free to write down your comments. I will be happy to help you out. Thank you for joining me, and I will catch you soon in the next video.